Hello and welcome to part 6 of the Procedural Planet series in Unreal Engine 5. In this tutorial we're going to be going over how to spawn foliage like trees in PCG, which is the Procedural Content Generation System in Unreal Engine 5. It's pretty sweet. We're going to do some tricks and we're going to get it going, and we're going to add a water surface material. So without further ado, let's get started. Alright, so before we get started, we're going to convert our Mars planet back into the Earth style planet by changing the colors. So if you remember, our terrain basic 2 is the newer material we were using. You're going to right click that and we're going to create a material instance, because it'll be faster to do this instead of trying to like change all the colors back. And I think if we just drag that on, we might luck out. Fat chance. Okay, so we're gonna open up our Mars planet and our blue planet. I'm just calling it Mars because it's easier. It's not actually Mars. Go through and make sure you check all the same things up here, and then just copy these values and paste them in. Ooh, can we copy all these? Copy all properties in group. Ooh, and paste all properties in group. Oh, saves us time, saves us a headache. Whoever came up with that little thing, we salute you. Okay, so that will allow us to like spawn our trees and have it look more realistic, because you don't have trees in the desert. You have shrubs, shrubberies, and cacti. Okay, so here's our big planet. We're going to work with the big one. The small one, which is the old version with the noise and world space, which transforms and all that, is the old way. We're going to work with the newer way. And yeah, on to the next step. Okay, before we begin, I want to add a little disclaimer that there's a couple ways to do this. The way we're going to do it is probably a quick and dirty, easy way. You can actually create a custom mesh sampler for dynamic meshes, which I've done, and it'll take its own whole video. And it's pretty cool, but for this tutorial we're keeping it short and simple. So we're going to start by just right clicking, going into PCG, and we want to create a PCG graph. We're going to call it PCG dynamic planet, and we're going to open that. So that'll give us this, and the first thing we want to do is we're going to use a world mesh query, world ray hit query. You could use a mesh sampler, but if you go to mesh sampler, you're going to notice really quick that it wants static mesh, and it just doesn't play nicely, and we don't want to convert everything to a static. In this case you might want to, but for the purpose of this series we're keeping it dynamic. Okay, so we're going to do world ray hit query. Ooh, volumetric query, that sounds interesting. And before we do this, I believe we need to drag our graph into the map. So that's another thing about PCG. There's a couple ways to do this. One way is to create a volume around your object and then work that way, and the other way is to create a component on the object. That way that PCG graph can access the component. We're going to do a volume for this. The other way is better for the mesh sampling method, but for this purpose we're going to go with the volume. And I think it's because it helps the world ray hit query work better. So drag this little guy or graph into the world and notice its position. So click your planet, right click location, copy, grab that thing again, paste the location in there. You're gonna know it's very small, so we need to make it bigger. For brush settings I usually go like 1000 and then just scale. It's like the magic unit. What do you think, like 25? Oh, it's already scaled. 25, 60 maybe? 60 it is. Cool. Alright, so there's our little baby planet and our bigger planet. Next step, we got our world hit ray hit query. We want to, what do we want to do? We want to sample the surface that we hit. We're going to start there. Let's make sure we have all these options. Ooh, you can set ray parameters. We're going to do that real quick, but we're going to mess with that later. This is how you get ray origin and ray direction and length. So now if you hit A, we're not getting anything in here. So by the way, this is PCG. If you haven't touched it. It's an extremely powerful tool. I'm diving into it right now. And coming from Houdini, which is like all about attributes and points, it's awesome, but it's really a pain in the ass to learn. It's got a learning curve that kind of sucks because it's just a different way of handling things, and the wording for nodes is different. But stick it out and you're going to find that it's powerful. Very powerful. Okay. I think it's going to be used a lot more in the future of Unreal Engine, in my opinion. Otherwise, we'd have to like spin our own spawning things and blueprints every freaking time, and we don't want to do that. Okay. I'm ranting. Alright, so if you're... Okay. So, right now we're not getting any information or data from our surface sample, and that's because our world ray hit query doesn't know what to look for. So go to filtering under world ray hit query, go to tag filter and say include tagged, and we're going to say actor tags list. We're going to say dynamic mesh actor. Save that, and then we got to add that tag to our planet. So click that and edit that mesh. Go to the self. If you search tags, and you want actor tags, not component tags. So in actor tags, you'll type in dynamic mesh actor, or whatever you want, as long as the tags match. And now, hopefully, I said hopefully, let's check filtering, include tag dynamic mesh. We're missing something. We're missing something. So what we're missing is that we need to add a collision setting to our dynamic mesh component, which is in our object. So if you go to BP Planet Mesh, down to dynamic mesh component, and then you switch collision to, we're just going to use complex. Collision is simple, just, I mean, it's probably too expensive. You could probably do it the opposite way, but I'm just doing that for now. We don't have a lot of we do have kind of a lot of triangles, but whatever. Like, you can switch these where you use simplest complex and then just enable it. You get the idea. We just want to make it work. So that should work. This is something weird that drives me nuts. Like, if you're getting this, it's not doing anything. Sometimes, like, maybe just jiggling it a little bit. I don't know. There, and it worked. So we jiggled it, and then Control Z to get it back in the center. So if you hit A on your surface sampler, we should now see that we have a bunch of points, only 2,000, which is good. You can adjust that by the points per squared meter, and you don't want too many. So if you hit D, which is for debug, which also is this little checkbox right here, you can just press D as the shortcut, A for attributes. And D will show us those little cubes, and they have a density applied to them, which is why they're black and white. So now we can see that the rays are being cast from above, and they're scattering down on the planet. So we're going to have areas that don't get hit in the shadow of these areas because it's coming from above. So for our quick and dirty purposes, we're going to do a ray cast from above and from below. Again, ideally you would just do a mesh sample, but that will take like 20-minute video, and we're just gonna do quick and dirty way. So remember how we have this set ray parameters thing here? We can check that, and we have ray origin. If we copy and paste this thingy, this node world ray origin, and we want to set a custom origin and a direction. Actually, I remember thinking that we could make this an input. Excuse me. Also important, in your world ray hit query under attributes, excuse me, check get impact point, get element index if you want, and if you want you could throw some other things in there, like maybe distance could be useful. I was going to use the distance node. That might be useful. Maybe not. Yeah, back to this. Here we go. So you can see when you drag these down, it has all these things. We want ray origin. Drag that out, type in a constant. I'm going to say create constant. You can name it whatever you want. I don't know if we need, you know, instead of doing this, you can do this. I recommend doing it this way, but that's just going to cause us confusion. You can also just take your ray origin and hard code it in. So right now, can't see, but our location is, copy the location of the planet, paste it into ray origin, and then in the Z, just negate the Z. And in theory, that should make it go down. Unless you're already in the negative, then that'll make it go up. So just imagine wherever your planet is, whatever it is, Z is, just make the Z below the planet. So that might be different for you than what it is for me. And ray direction is right now is -1. Just put that to +1 on the Z, and that'll spit upwards. So now if you combine these two here, we should see dots being, or points, cubes being placed on the bottom half of the planet, and we are. This fog is pretty thick. So that's the basics of, very basics of scattering some points on the surface using the world ray trace. Again, other ways to do it, but this is going to work for our purposes. And we're going to increase our surface sampling. So maybe instead of 0.01, we'll put 0.1. That'll give us more points. That's weird that we're not getting as much in certain areas. I don't actually like that for this. Alright, technical difficulties, but it was actually me just not realizing that our planet is a lot bigger than I expected. So if you're using the 2 world ray hit queries and it's not going all the way down underneath, you probably need to change your origin to be even further below the Z. So copy and paste your ray origin location from the planet and then change the Z to be like -30,000. And just make sure that your ray length is larger than that, and you should get hits all around the bottom and from all around the top. There'll be a slightly less in areas that are the shadows of large mountain ranges, but a lot of the times that's going to be under the ocean anyway, so let's not worry about it. We're on a time crunch right now for this tutorial. So yeah, that's our surface sampler. So again, this surface sampling method is not perfect. There's triplanar, you can do 3 from triangles or 4 or more just from all around, and then cull out the points so you don't have too much density. But for our tutorial, we gotta keep chugging along. So our next move is, let's just go straight to spawn a mesh. So if we go static mesh spawner, like, let's not mess around. Let's go straight to it. And we're gonna go into mesh selector, mesh entries, down here into static mesh. I think if we type PCG tree, no, it's not gonna let us. It's not gonna let us. I hate that. So scroll down into engine on our folders on the bottom left, plugins, probably search plugins for PCG, and we want the sample, which if you highlight them, maybe if we type sample content, for some reason there's 2, but we want the top one. We're gonna go in here to say simple forest meshes. Wow, that was a mouthful. So the line is plugins, procedural content, framework, sample content, simple forest meshes, grab PCG tree 01, and have this hanging out here so we can drag and drop that into static mesh. Boom, that's a lot of trees. So that's a little too much density. Let's go back to 0.01. That's a little better. I'll make that 0.03. Too much. 2 is probably the sweet spot for now. Alright, now we've got trees all over our mesh, press D to get rid of the debug cubes, but we don't want trees in the ocean, obviously. Maybe you do, I don't. And we also don't want them at the top of a tree, so we need to create a filter to filter out those tree meshes that we don't want. Alright, so next thing is to filter, and remember how we checked impact distance on our world ray hit queries? It turns out that's not going to work for us, but I want to make a point about it because it could be useful for you later on. So if we do attribute filter and we change target attribute to impact distance, and we want a constant threshold, which is use constant threshold right there. If you sort these impact distances, you'll see that we have from like 3,000 to like 37,000. Let's just pick a number like 25,000, and we're going to say if it's greater than that, and that'll filter this out. We should see it anyways. Should, famous last words. What happens if I type 10? 30. Oh, whoops, you gotta get rid of that. So yeah, make sure you control your wires. 25,000, you turn off D there, and you'll notice that it's only trees are spawning in the middle, and that is because with impact distance it's actually measuring the distance from the origin of the rays, which is above and below, and so anything greater than 25,000 it is spawning, which is happens to be in the center. So you could control what types of like trees and shrubs or foliage you spawn based on distance towards the equator, if that makes sense, which is useful, but we're not going to do that right now. I just want to show you that. So instead, let's delete that. We're going to do distance, and our source will be these surface samples, and our target will be get actor data. Do I need to full screen this? Probably. No. Get actor data down below. Plug that into there. Error. Tried to generate too many points. We might want to switch these. We'll see. But anyways, self actor do. Okay. Oh. That should not have that many points. That should be single point. Oh, we need to get single point. Where is get single point? Mode. Get single point. Whew, that's important. So that's why it would almost crash your computer. So now we get the single point on your get actor data. You get position X, position Y, position Z. You're going to check the distance between each surface sample, and now we should see that there are distances, and they're all negative for some reason. I don't know why. That's just the way it is for now. Type in abs and you can get absolute value, and we want our input source to be distance. So if you hit A on that, that should fix that issue. So now you can see that distance is actually different from impact distance, as we expect. So now if we filter by that, we want attribute filter, and we're going to say greater than, our target attribute is distance, and we want to use constant threshold. Let's bring this out here real quick. What was a good number for kind of in the middle? I don't know, 20,000 for now. We'll say inside filter, which means if it's greater than that, we will spawn. So let's keep our thing in view, and we're going to tweak our attribute filter settings. Okay, we might have to switch this at some point. 28,000. Let's go 28,500. 27,500. Alright, so that took care of all the stuff, not quite all the stuff. 27,000. 26.5. There we go. So that takes care of the stuff that was in the ocean, mostly, except for here and all these weird shadows we don't want. 6,000. Go with that. Okay, 26,000 is a magic number roughly for this planet. It'll be different from yours, but also it looks like we're not spawning points there, which is unfortunate. And there, also unfortunate. Hold on, hit D. There are points there, but they're not. If you notice that your trees don't seem to be lining up quite right and like the distances should work but they're not, make sure your volume is in the same location as your planet, because as you saw before, we kind of jiggled it and we didn't get it back to its location, so that's why my trees weren't lining up based on their elevation, because the distances were offset slightly. So center that, should fix your issues if you have that. Okay, moving on. We want a filter. We also want to filter the stuff that's up high. So we need another filter. We'll just add, let's copy and paste that. Go in, snip that line there. And now we're working with the height. 26, 1, 2, 3. So that's deleting that. If we hit greater than. Okay. Play with your filters, less than, greater than. It makes sense when you think about it, but it doesn't make sense to me all the time, because it's like, what is the distance measuring from? Is it from the center outward or the outward towards the center? Why is it negative originally, etc.? So I put greater than in this case. So if it's greater than 26,000, we want to maybe like make this 250 maybe. No, we want it smaller. 25.5. Too much. 25.750. That's pretty good. Call that good enough. Oh, and we got trees at the poles that we don't want. So that actually might be a good use case for our one attribute filter for impact distance. So if we do another filter, and we'll say we'll do impact distance for this one, and we want it to be, we want to keep anything that's greater than a certain value. So if we go to impact distance, you can see around 4,000. Here, let me drag this over so you can see. Impact distance around the 4,000 seems to be the sweet spot. So use constant threshold. For an actual procedural setup, you're not going to want to use constant thresholds most of the time, but for testing purposes, it works pretty good because it's fast and easy to try values. 5,000. 8,000. Boom. Alright, that cleared the trees at the poles, so we no longer have trees spawning there. We have trees spawning at the correct elevations for our, I don't know, forests. So it's not spawning in the mountains and it's not spawning in the ocean. And that wraps up the basics of this PCG foliage spawning part of the tutorial. It's very basic, but it teaches you how to filter by attribute. It teaches you how to get distance from the attribute and use world array hit query as well as a surface sampler. And that is like the bread and butter of getting started with procedural content generation. So our next step is, just to make it look a little nicer, we're going to add a water surface. Okay, to add the water, we're just going to do a real quick and easy hack. It's not a hack, but I call it a hack because it's kind of janky. I don't know. What do we got? We want to go to Window, Place Actors, find Shapes, grab a sphere, drop it into here, close that. Then scroll on the left down towards Engine in the little folder section, and in search type water. You should have this water shader. We're going to duplicate it. It says water 1 now. Scroll this back up to your wherever you're working. I think I'm in planet. Move or drag and drop, set move here. Right click, create material instance, and then with your sphere selected, you're going to drag and drop the material onto that sphere, and then click your planet right click the location, copy, click the sphere again, paste the location there. With the planet selected, you're going to scale this up probably 250. Well, first, you can check this little lock icon so it scales all of them evenly. Too small, 750. Too big, 500. Ooh, 500 is actually pretty close. 505. 505 is pretty good. 507. 508. 510. Pretty close. 515. Oh, too much. 511. 512. About that. 511 maybe. It's kind of taking over some of the beach. We'll just start with there. Anyway, so find the right scale for your planet's surface, water surface. Now that we got that instance, you can open that up. And then move this off to the side. You will want to open up these values. We want max depth, turbidity, and watercolor. So if you notice, there's like weird reflections. You'll probably want to get a better way to get rid of those reflections, but for now an easy way is just to increase this value to like 100 or something, 50, whatever. So that gets rid of those weird surface reflections, and then change the watercolor. I personally don't like the default one so much for this like kind of stylized look, you know. Anyway, adjust that to however you like, make it look all nice and stylized tropical. That gives us a nice little surface. For there you can change the wave size, flow, and effects. I don't think we need spherical caustics, so I unchecked that. One more thing I wanted to add real quick, because it's just something I took for granted because I figured you guys have probably seen it, but if you want to change the scale of your trees, you can go to transform points, and we'll do unplug that real quick, plug that into there, and I mean ideally we'd be able to see more on the screen. If we go to scale min to like, I don't know, 0.7, oops, that's supposed to be 0.7. Obviously our scale is not to scale, because this is just like an example, and maybe you want to go like even bigger, like 1.3. Just realized that these automatically does that. So you have different scale and variation. You can do some rotations, like rotation min from 0 to 360. No, we don't want that. We only want it on the Z. There we go. And maybe a little bit of tilt. Let's see if we go 5 and 5. I'll give us a little bit of tilt on the trees. We got some scale variation. And you can just add in a seed if you want. And I think that is good for us for now. So yeah. That gives us some variation in tree size, some variation in tree rotation. And from there you can spawn different types of trees. You can filter by different attributes, but that's a good start. So hope that helps give you an idea of how to get going. I'm not sure what the next video would be in this series. I might wrap up for this series and I might move into doing more procedural content stuff. I'm thinking about doing some procedural destruction of buildings, and I'm going to keep working on some other things. Ooh, a good next video might be moving towards using landscape type materials instead of just these basic colors for our mesh. So I don't know. Anyways, that's the basics of PCG spawning foliage on a dynamic mesh actor such as our planet. Hope you enjoyed. Until next time, peace.